question, remove duplicates from sorted array. It's an easy level array question. The question states given an integer array nums sorted in non-decreasing order, remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same. Since it is impossible to change the length of the array in some languages, you must instead have the result be placed in the first part of the array nums. More formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final result. It does not matter what you leave beyond the first k elements. Returning k after placing the final result in the first k slots of nums. Do not allocate extra space for another array. You must do this by modifying the input array in place with O1 extra memory. Let's look at the example 1. Input nums equals 1, 1, 2, and then we output the k, which is 2, with 2 unique elements. This is an underscore because they don't care what is left in the array as long as you tell them the first 2 are your final results in nums, and you modify nums in place. So looking at this question immediately, I can think of a brute force way to do it. It might not be the best time complexity, but the simplest writing in code would be a set is a Python function that removes duplicates, and the result of the set is unordered, so we can set nums, and this will remove all the duplicates. And then since this array is already sorted, we just need to sort the array again. So we'll modify all of the numbers inside nums to sorted set nums, which will remove the duplicates, and in the end we need to return k, which is the length of the new nums. But this is not the best time complexity because set in Python is implemented using hash, while set only uses O1 time complexity. Sorry. I can write this down. So set function uses O1 time complexity, but sorted function uses O and log n. So the time complexity for this entire code would be n log n. And then the space would be, since we're not allocating any new space for this, it would be O1. But this is not the best time complexity. Let's just run this first. There's a way we can use 2-pointer to solve this question using time O and space instead. In space. So let's try the 2-pointer way. The 2-pointer way to solve this is we can have k as starting at 0, pointing to the zeros index, and then we can have a for loop that goes through the entire array of nums, so for n nums. And we check for if there's duplicates, like k is basically our left pointer, and our right pointer is this n nums. So we check if n does not equal nums k. So at any point we step through all the duplicates, and if we find there are different numbers, then we increase the time pointer by 1. We don't want to remove any numbers, and we rewrite the nums k, which is +1 now. For example, if k points to 1 and this goes through the list, n is 1, 2, so it doesn't go into here. It goes to, now n goes to 1, k is still at 1, it's still the same, and it wouldn't do anything. And then when k is 1 and then n is at 2, they're different now, so they no longer equal each other. So then we want to rewrite the k plus 1 to nums k equals n. So then it would be rewritten to 1 and 2. And then in the end, we just need to return the k value. So let's see, nums 1, 2 would return 2, but in the end, k is at index 1, right? So index is always 1 smaller than the actual length of what's in here, so we just return k plus 1. And the time complexity of this is O n, because we only go through the array nums once, and we don't allocate any extra space, so the space is also just O1. So this is how I would solve this question using 2 pointers. Thank you so much for watching.